In today's video, we're going to talk about hypotheses, variables, levels of measurement, and levels of evidence. A hypothesis is a speculative statement about a difference or a relationship. The difference could exist between groups on some factor or within a single group over different time points. It's important that hypotheses should be specific, concrete, and testable, and they should contain information about the dependent and independent variables, more on what those are later, how those variables will be measured, again, stay tuned for levels of measurement in this video, and the duration of the investigation and the type of subjects involved. All of that should be contained in a specific statement that you can then test in a research study. We hypothesize and phrase things differently, depending on what we're expecting to find. And they can be phrased in three different ways. The null hypothesis is a statement that no difference or relationship exists. Statisticians prefer the null hypothesis as that's what we're really testing when we test with statistical methods. But how useful is it to study something that you don't think exists? So we turn to something like a non-directional research hypothesis, and this states that a difference or relationship exists, but it doesn't speculate on the direction or the difference or the relationship. So it just says it exists. In a directional research hypothesis, we state that a difference or relationship exists and we predict the direction. For example, that group A will be higher than group B on the factor of interest, or that there will be a positive relationship between the two factors under study. So those factors within a hypothesis are known as variables. There's always a dependent variable. This is the factor that you want to explain in the case of a relationship study or change in the case of a different study. And we call it the dependent variable because the value of this variable is dependent on the effect of another variable, the independent variable. Again, this variable is always present in the study, and it's the factor that you think will explain or cause change in that dependent variable. It's the characteristic that's being observed or manipulated in the study that is hypothesized to be doing the influencing. There are other types of variables that can be present or add bias or uncertainty to the relationship between that dependent and independent variable. They're not always present in a study, and sometimes it's hard to determine if they are in fact present. They include things like an intervening variable. An intervening variable is a variable that influences the dependent variable and is itself influenced by the independent variable. So it occurs on the causal pathway between the independent variable and the dependent variable. So the dependent variable is the thing that you're wanting to explain the change in. And so in this case, the intervening variable acts on the dependent variable, but it is first acted on by the independent variable. So the independent variable acts on the intervening variable, which causes variation in the dependent variable, and it obscures the whole relationship under study. A confounding variable is a variable that travels with or is associated with the independent variable, and actually is the thing that is responsible for the variation in the dependent variable, not what you think is, or the independent variable. So in this case, a confounding variable is associated with both variables, but it isn't necessarily on the causal pathway like the intervening variable is. Finally, there's an effect modifier. An effect modifier is a factor within a person that modifies the effect or relationship between the independent and the dependent variable. All of these will become more clear when we talk about examples in class. Moving on to levels of measurement. We're going to use the term or the acronym NOIR, so black in French, N-O-I-R, to help remember the hierarchy associated with levels of measurement. N is the lowest level of measurement. It stands for nominal. Basically, you're classifying things into unordered, qualitative categories. There is no inherent order to these categories and no meaning behind any numerical value associated with them. A good example of this is country of birth. They just become bins that you classify people into. I was born in Canada. Someone else may have been born in the United States, for example. Moving up a level, O stands for ordinal. In this level, you're now classifying responses into ordered categories where the values have a distinct and known order or rank associated with it, but the categories are still qualitative in the sense that there's no numerical distance between the possible values. A good example of this are places in a race. You know that whoever placed second came after the first place person and before the third place person, but you don't know anything about how many seconds elapsed between the times of their finishes. I stands for interval. This level, values are assigned a natural distance between them so that a particular interval between two values in one region of the scale meaningfully represents the same distance between two values in another region of the scale. There's equal distance between each point on the scale in an interval level scale. A good example of this is temperature using the Celsius scale. The difference between 13 degrees and 14 degrees, 1 degree, is the same as going from 20 to 21 degrees. You're increasing by 1 degree of temperature. We all know what 1 degree of temperature feels like. Finally, the highest level of measurement is ratio, or that's what the R stands for. And basically what a ratio level scale is an interval level scale with a true zero. And that true zero means that there's an absence of the phenomenon of interest when you have a zero score. So for example, money as measured by cents, 1 cent is again the difference between 24 cents and 25 cents. And it's the same as between 98 cents and 99 cents. But if you have 0 cents, you have no money. You have a true zero. All right, moving on to levels of evidence. A quick Google search will yield many confusing scales with different images and different terminology to use to be explaining those levels of evidence. They all make the same point though. All research is not created equally. Each research design has its own biases that it's susceptible to, and it only allows you to conclude certain things based on how you designed the study. We'll get into that as we get into the later half of the course where we talk about specific study designs. For now, I want you to focus on this image that shows the pyramid or hierarchy of research study designs to illustrate this point. Along with this information, you have information about the potential for bias on the left-hand side in those study designs, and the strength of evidence related to determining causality as well. And on the right-hand side, you'll see the concluding statements that can be made at the end of those types of studies and how they increase as rigor increases. At the bottom of that hierarchy, we have expert opinions, or in the case of what we learned about in our last video, it's evidence learned through the method of authority. And you can see that we have a large potential for bias, no ability to infer causality, and weak concluding statements that come out of that method, which is why we use the method of science. So as you move up that pyramid, each research design provides more rigor, which is established through more control of the study. That gives us less potential for bias, provides stronger evidence of causality, and allows for stronger concluding statements to be drawn. What's missing, though, at the top of this pyramid is the recognition that if you pool many rigorous studies together in a synthesis, such as a systematic review or a meta-analysis, and we'll talk about what those actually mean later on in the year, you'll have the least chance of bias, a stronger evidence of causality, and more concrete and robust conclusions that can be drawn from that larger pooling of studies. If this concept is still unclear to you, there are more examples of levels of evidence and different ways you can conceptualize this in your textbook on pages 28 to 34.